The shocking opening premise. You've never touched anything. Not once, not ever, not in your entire life. Right now, you think you're sitting in a chair. You think your body is making contact with the surface beneath you. You can feel it. It's solid. It's real. You're touching it. Wrong. You're hovering. Right now, nanometers above the chair, your atoms and the chair's atoms are repelling each other with electromagnetic force so strong that they never actually make contact. Never. When you hold your phone, you're not touching it. There's a gap. Tiny, invisible, but real. Your hand's electrons and the phone's electrons are screaming at each other to stay away. They push against each other with such force that it feels solid, but they never touch. When you walk, your feet never touch the ground. You're floating, nanometers above the surface. The atoms in your shoes and the atoms in the floor are like magnets with the same poles facing each other. They repel, always, forever. Every handshake you've ever had, every hug, every kiss, every time you've held someone's hand, petted a dog, felt rain on your skin, there was a gap. Atoms pushing against atoms, getting close, closer, but never actually making contact. This isn't poetry. This isn't a metaphor. This is physics. You have never touched anything, and you never will. Think about that for a second. Everything you think you know about the physical world, everything you think you understand about contact, about touching, about things being solid, is wrong. It's an illusion your brain constructs from electromagnetic forces. When you sit down and feel the chair supporting you, what you're actually feeling is the electromagnetic repulsion between the electrons in your body and the electrons in the chair. They're pushing against each other. That push, that force, that's what your nerves interpret as touch. But there's no contact, no atoms ever merge, no surfaces ever meet. This should bother you. It bothered Feynman, because if nothing ever touches anything else, what does it mean for something to be solid? What does it mean to make contact? What is touch? Most people never ask, they just assume. You touch things, that's obvious, you can feel it, case closed. But when you really dig into what's happening at the atomic level, when you ask what atoms are actually doing when two objects seem to touch, you discover something so strange, so counterintuitive that it changes everything. The chair doesn't hold you up by touching you. The ground doesn't support your weight through contact. Your hand doesn't grip objects by making physical connection with them. Everything is force, electromagnetic force. Electrons repelling electrons. That's it. That's all touch has ever been. And here's the really wild part. This isn't some edge case, some weird quantum effect that only matters in labs. This is every interaction you've ever had with every object in your entire life. Every single one. You've lived your whole life in a universe where nothing touches anything else, and you never knew it. Atoms are mostly empty space. Let's go deeper, because the reason nothing touches gets even stranger when you understand what atoms actually are. An atom is mostly nothing. Not mostly like 60% empty or 80% empty. We're talking 99.999999% empty space. If an atom were the size of a football stadium, the nucleus would be a marble sitting at the center of the field. And the electrons, they'd be tiny specks orbiting somewhere up in the nosebleed seats. Everything in between, nothing, empty, void. Your hand is made of atoms. The table is made of atoms. Both are almost entirely empty space, so when you put your hand on the table, you're bringing two clouds of mostly nothing close together. Empty space approaching empty space. And yet somehow, your hand doesn't pass through the table. Somehow these empty structures feel solid, hard, real. This is the paradox Feynman loved. Think about it. If atoms are 99.9999% empty space, why can't you walk through walls? Why doesn't your hand phase through the table like a ghost? The actual solid matter, the stuff with mass, is such a tiny fraction of the total volume. The rest is just space. You are mostly empty space. The chair you're sitting on is mostly empty space. The entire room around you, every object, every surface, it's all mostly nothing. So what's stopping everything from passing through everything else? Not physical contact, that's already off the table. We established that nothing touches. The atoms never make contact. What's stopping you is force, electromagnetic force. And it's absurdly strong. Here's how it works. Every atom has electrons orbiting around a nucleus. Those electrons carry a negative charge. When two atoms get close, their electron clouds start to overlap slightly, and electrons hate other electrons. Same charge, same repulsion. They push away from each other with tremendous force. That force, that electromagnetic repulsion, is what you feel as solidity. It's not contact. It's repulsion so strong that it stops atoms from getting any closer. The closer atoms get, the harder they push against each other. The force increases dramatically as the distance decreases. So when you press your hand against a table, you're forcing the electron clouds closer together, and they're pushing back harder and harder. Eventually, the force is so strong that your hand can't compress any further. It feels solid, but there's still a gap, always. A tiny gap measured in nanometers, but a gap nonetheless. Now think about this. The nucleus of an atom contains almost all the atom's mass. Protons and neutrons packed together incredibly tight. The electrons orbiting around it have almost no mass. They're tiny, almost negligible. So when you hold a book, almost all the mass of that book is concentrated in the nuclei of its atoms. Tiny, dense points separated by vast expanses of empty space. The electrons, the things actually doing the work of repelling your hand, those have barely any mass at all. You're being held up by almost massless particles pushing against other almost massless particles. The actual mass, the stuff with weight, is sitting deep inside the atoms doing nothing. It's just there, existing, while the electrons do all the work of making things feel solid. Feynman thought this was hilarious, all this mass, all this weight, and it's just sitting there in the nucleus, useless for making things solid. The thing that makes objects feel real, feel solid, feel like you can touch them, that's the electrons. And they barely weigh anything. Here's another way to think about it. If you could remove all the empty space from all the atoms in your body, if you could compress everything down so the nuclei were actually touching each other, no gaps, no space, just pure matter, your entire body would be smaller than a grain of sand. All of you, every atom, compressed down to pure matter, grain of sand, and yet you feel solid, you feel real, you take up space, you can't walk through walls. Why? Because empty space isn't really empty, it's full of force, electromagnetic force radiating out from electrons, creating barriers, making structures, holding atoms apart even though there's nothing physical between them. The universe is held together by forces acting across empty space, not by things touching, not by physical contact, by invisible forces pushing and pulling on each other constantly. And those forces are so strong, so consistent, that they create the illusion of solidity. They make atoms act like little hard spheres even though they're mostly nothing. They make objects feel real even though they're almost entirely empty. This is what matter actually is, not solid stuff, not continuous substance. Matter is tiny, dense points surrounded by force fields, separated by vast distances, never touching, always repelling, creating the appearance of solidity through pure electromagnetic interaction. You are not a solid object. You are a cloud of forces, a pattern of repulsions, empty space organized by electromagnetic fields into something that feels real. And nothing, not one single atom of you, has ever touched anything else. Electromagnetic repulsion, the real force. So what exactly is pushing back when you press your hand against a wall? It's not the wall's hardness. Hardness doesn't exist. Not really. What you're calling hardness is just electromagnetic force. Nothing more. Here's what's actually happening. Your hand gets closer to the wall. The electron clouds surrounding the atoms in your hand start getting near the electron clouds surrounding the atoms in the wall. And electrons have a charge, negative, all of them. Same charges repel, always. This is fundamental. You can't negotiate with it. You can't turn it off. Electrons repel other electrons, period. So as your hand approaches the wall, billions of electrons in your hand are getting close to billions of electrons in the wall. And they're all screaming at each other. Stay away, get back, don't come closer. The closer they get, the louder they scream. The force increases, not linearly. It grows dramatically as the distance shrinks. Push your hand harder against the wall, force the electron clouds closer together, and the repulsion skyrockets. That's what you feel, that resistance. That's not the wall being hard. That's billions of electrons pushing back against billions of other electrons with electromagnetic force. Remove that force and the wall would offer no resistance at all. Your hand would pass right through it. The atoms would just slide past each other because there's nothing physically there to stop them. Just empty space and tiny nuclei. But the force is there, and it's absurdly strong. How strong? Strong enough to hold up buildings. Strong enough to keep the ground from collapsing under your weight. Strong enough that you can hit a wall as hard as you want, and your hand will never, ever break through at the atomic level. The atoms will never touch. They'll just repel harder and harder until something breaks. But what breaks isn't the electromagnetic force. That's still there. What breaks is the structure. The bonds between atoms get ripped apart. The material fractures. But even in the broken pieces, atoms still aren't touching. Think about hitting a punching bag. You swing your fist, it connects. The bag deforms. Your fist slows down, stops. It feels like impact, like contact, but there's no contact. What happened is this. The electrons in your fist got very close to the electrons in the bag's surface. The force between them increased dramatically. That force decelerated your fist. The energy from your moving fist transferred into deforming the bag, making its atoms move, making them jiggle faster, heating it up slightly. Your fist never touched the bag never touched your fist. They just exchanged energy through electromagnetic fields acting across empty space. Every impact you've ever experienced works this way. Every collision, every bump, every crash, every time you've stubbed your toe or caught a ball or clapped your hands together, electromagnetic force. That's it. And here's something that should blow your mind. That force isn't coming from the nuclei. The nuclei are sitting deep inside the atoms, locked away, surrounded by electrons. The nuclei are positively charged, yes, but they're so small and so far away from each other that their electromagnetic influence at these distances is almost nothing. It's the electrons doing everything. These tiny, almost massless particles are creating all the force you've ever felt. Every surface, every texture, every sensation of hardness or softness, rough or smooth, that's electrons interacting with electrons. The nucleus just sits there. It's got almost all the mass, almost all the weight. But when it comes to interactions between objects, when it comes to what makes things feel solid, the nucleus does nothing. It's just baggage. The electrons are running the show. And they're doing it with one rule. Stay away from other electrons. That's it. One simple rule. Same charges repel. And from that one rule, you get everything. Structure, solidity, the feeling of touching something, the resistance when you push against a wall, the bounce of a ball, the grip of your hand around an object. All of it is electrons repelling electrons. Now think about this. You've been told objects are solid. You've been told atoms are like little balls that stack together to make stuff. That's wrong. Atoms aren't balls. They're clouds, probability clouds. Regions where electrons are likely to be found, and those clouds overlap. When two atoms get close, their electron clouds start to occupy the same space, not completely, not perfectly, but they begin to merge slightly at the edges. And that's when the repulsion kicks in. The electrons don't want to be in the same space. They push back. The force increases. The clouds compress, but resist compression. And that resistance is what you feel as solidity. But here's the key insight Feynman kept coming back to. This is all happening in empty space. There's nothing physical pushing against anything physical. It's just force, fields, electromagnetic fields extending through the void, pushing on other fields. You're not touching the chair. The electromagnetic field from your electrons is pushing against the electromagnetic field from the chair's electrons. Force meeting force, field meeting field, nothing touching anything. And the crazier part, this force operates at the speed of light. When you push on a wall, the information that your hand is there, that force is being applied, that travels through the electromagnetic field at light speed. It's almost instantaneous at human scales. But it's still traveling, still propagating through space. The wall doesn't know your hand is there until the electromagnetic field from your hand reaches it. Then the wall's field responds, pushes back,
and you feel that response as resistance. It's all fields, all force, all electromagnetic interaction happening in empty space at nearly the speed of light. And your brain interprets this as touching something solid. The universe has been lying to you your entire life. Or rather, your senses have been translating electromagnetic force into the sensation of touch because that's useful. That's how you survive, but the underlying reality is stranger and more beautiful than the illusion.
The Pauli exclusion principle. But wait, it gets weirder. Because electromagnetic repulsion isn't the only thing stopping atoms from overlapping. There's something deeper, something more fundamental. The Pauli exclusion principle. This is one of the strangest rules in all of physics, and it's absolutely essential to understanding why matter exists the way it does. Here's the rule. 2 electrons cannot occupy the same quantum state in the same place at the same time. That's it. That's the whole principle. Sounds simple, but the implications are staggering. What does it mean for electrons to be in the same quantum state? Every electron has properties: spin, energy level, position, and in quantum mechanics, these properties are described by something called a quantum state. It's like an address, a unique identifier for where the electron is and what it's doing. The Pauli exclusion principle says no 2 electrons can have the same address, not in the same atom, not in overlapping atoms, nowhere. If you try to push 2 electrons into the same quantum state, the universe says no, absolutely not, cannot happen. The rules of quantum mechanics forbid it. And this isn't just a polite suggestion. It's not like electrons prefer not to overlap. It's that they cannot overlap. It's impossible. The math doesn't allow it. The universe doesn't permit it. Now here's where it connects to touch. When you push your hand against a table, you're trying to bring the atoms in your hand closer to the atoms in the table. You're trying to make their electron clouds overlap more and more. But those electron clouds are full of electrons, and those electrons are in specific quantum states. As the clouds get closer, as they start to overlap, some of those electrons would be forced into the same quantum state. Same position, same energy, same spin. And the Pauli exclusion principle says, no, stop, cannot happen. The electrons resist, not because they want to, not because they're making a choice, but because the fundamental rules of quantum mechanics forbid them from occupying the same state. That resistance, that refusal, that's what you feel as solidity. That's what stops your hand from passing through the table. Feynman loved this. He thought it was one of the most beautiful insights in all of physics. What we call touch, what we experience as solidity, as objects being real and impenetrable, that's just quantum mechanics refusing to let matter overlap. It's not physical contact. It's not even just electromagnetic repulsion, though that's part of it. It's the universe enforcing its rules. The Pauli exclusion principle saying electrons cannot be in the same place doing the same thing. And because of that rule, because of that fundamental constraint on how electrons can behave, matter can't pass through matter. Atoms can't merge. Objects stay separate. You can't walk through walls. Think about how insane this is. The reason you don't fall through the floor isn't because the floor is solid. The floor is mostly empty space. The reason is that the electrons in your feet and the electrons in the floor cannot occupy the same quantum states, so they resist being pushed together. The floor holds you up not through any physical substance, but through quantum mechanical prohibition. The universe is running a background check on every electron interaction, making sure no 2 electrons violate the exclusion principle, and when they would, it says no and pushes them apart. You are being held up by a rule, a law of quantum mechanics. That's it. Now combine this with electromagnetic repulsion. You've got 2 forces working together. The electromagnetic force pushes electron clouds apart because same charges repel. The Pauli exclusion principle refuses to let electrons occupy the same quantum state, even if you could somehow overcome the electromagnetic repulsion. Together, these 2 effects create what we perceive as solidity. The electromagnetic force does most of the work at normal distances. But as you push harder, as you try to compress matter more and more, the Pauli exclusion principle becomes dominant. It sets the ultimate limit. You cannot compress matter past a certain point, because electrons will not violate the exclusion principle. This is why matter has volume. This is why objects take up space, not because they're made of solid stuff, but because quantum mechanics forbids the electrons from overlapping. If you remove the Pauli exclusion principle from the universe, if you turned off that rule, matter would collapse. All the electrons could fall into the lowest energy state. Atoms would shrink to nothing. Everything would implode. The entire universe would collapse into a dense soup of overlapping quantum states. But the principle is there. It's fundamental, it's non-negotiable, and because of it, matter exists as we know it. Objects have size, they have volume, they resist compression, they feel solid. And here's Feynman's insight that ties it all together. What we call touching something is really just experiencing the consequences of quantum mechanical rules playing out at the atomic scale. Your brain has no idea about quantum states or electromagnetic fields. It just knows that when you push against something, there's resistance, and it interprets that resistance as touch. But the reality underneath is stranger. You're not touching anything. You're experiencing the universe enforcing its rules. Electromagnetic force keeping electron clouds apart. The Pauli exclusion principle forbidding electrons from occupying the same quantum state. That combination, that's what solidity is. That's what touch is. That's what matter is. Not substance, not stuff. Just rules, forces, quantum mechanical constraints playing out across empty space, creating the illusion that objects are solid, that things can touch, that the physical world is made of tangible stuff. It's not. It's made of rules. And the rules say, nothing touches anything else. The mind-breaking conclusion. Let's bring this all back together, because what we're talking about here isn't just some quirky physics fact. It's not a fun bit of trivia to share at parties. This changes everything. Every sensation of touch you've ever experienced. Every single one. Holding a pencil, hugging someone you love, feeling the ground beneath your feet, taking a shower, eating food, petting a dog. None of it was touch. Not one moment of it. It was electromagnetic force. Always. Every time. The electrons in your hand repelling the electrons in whatever you thought you were touching. Force fields pushing against force fields across nanometer gaps that your brain interprets as contact. But there was never contact. There was never touch. Just force. Think about the first time you held hands with someone. That feeling, that connection, that warmth. You thought your skin was touching their skin. You thought there was contact, intimacy, physical connection. There wasn't. Your electrons were screaming at their electrons to stay away. The electromagnetic fields from your hand were pushing against the electromagnetic fields from their hand. You were hovering nanometers apart the entire time. The warmth you felt, that was heat transfer. Atoms in your hand jiggling faster because of proximity to atoms in their hand that were jiggling at a different rate. Energy moving between the two collections of atoms through electromagnetic interaction. No touching required. The sensation of texture, of feeling their skin, that's your neurons detecting minute variations in the electromagnetic force as your electron clouds slide across their electron clouds. Rough spots create different patterns of repulsion than smooth spots. Your brain interprets those patterns as texture, but there was no contact. You were floating above their hand, always, the entire time. Every memory you have of touching something is a lie, or rather it's a translation. Your brain took electromagnetic force data and converted it into the sensation of touch because that's useful. That's how you interact with the world. But the underlying reality is nothing like the experience. You've been floating through life, surrounded by force fields. Every object you've ever interacted with, every surface you've walked on, every chair you've sat in, every door you've opened, you've never actually made contact with any of it. You're like a ghost, passing through the world, interacting with it through invisible forces, never touching anything, held up by quantum mechanical rules and electromagnetic repulsion. The ground beneath your feet right now, you're hovering above it, nanometers above the surface. The electromagnetic force from the electrons in the floor is pushing up against the electromagnetic force from the electrons in your shoes with such strength that it feels solid. But there's a gap, always a gap. You're floating. You've always been floating. You'll always be floating. And it's not just touch. Think about what this means for everything else. When you look at something, you're not seeing the object itself. You're seeing photons that bounced off the electron clouds surrounding the object's atoms. The light never touched the nucleus. The photons interacted with the electromagnetic fields and bounced away, carrying information about the field's structure. When you hear something, you're detecting vibrations in air molecules that were pushed around by electromagnetic forces. Sound is just atoms bumping into other atoms through electromagnetic interaction, creating pressure waves that your ear detects. Smell? Molecules floating into your nose and interacting electromagnetically with receptors. Taste? Same thing. Molecules on your tongue binding to receptors through electromagnetic force. Every sense you have is detecting electromagnetic interactions. Nothing more. You've never experienced the actual substance of anything. You've only ever experienced the electromagnetic fields surrounding atoms. You are a pattern of electromagnetic forces detecting other patterns of electromagnetic forces. That's it. That's all perception is. Feynman understood this. He understood that reality at the quantum level is nothing like our everyday experience suggests. Nothing like what our senses tell us. Nothing like what feels true. We walk around thinking the world is made of solid stuff. Objects, things, matter. We think we touch them, hold them, interact with them directly. We don't. We can't. There is no direct interaction. There's only force, fields, quantum mechanical rules playing out in empty space. The chair you're sitting on isn't holding you up through its solidity. It's holding you up because the Pauli exclusion principle forbids the electrons in your body from occupying the same quantum states as the electrons in the chair. And the electromagnetic force between those electrons creates a repulsion strong enough to counteract gravity. You're being held up by mathematics, by the fundamental equations of quantum mechanics, by force fields, not by stuff. And this isn't just true for you in the chair, it's true for everything. The entire universe operates this way. Atoms interacting through forces, never touching, held apart by electromagnetic repulsion and quantum mechanical rules, creating the appearance of solid matter through pure mathematical constraint. Stars, planets, oceans, mountains, cities, people, all of it is mostly empty space held together by forces. None of it is solid in the way we think of solidity. None of it involves actual contact. Here's what should really break your brain. The atoms in your body right now, they're the same atoms that were in other things before. Carbon atoms from the food you ate, oxygen atoms from the air you breathed, hydrogen atoms from the water you drank. Those atoms were never part of you. They were never part of the food, the air, the water either. They were always just atoms, floating around, interacting through forces, temporarily organized into patterns we call a person or an apple or the ocean, and they never touched each other. Not when they were in the food, not when they entered your body, not now. They're just near each other, repelling each other, following quantum mechanical rules, creating the pattern that is you. You are not a solid object. You are a temporary arrangement of atoms that are mostly empty space, held together by forces, never touching, constantly being replaced as new atoms cycle in and old atoms cycle out. The you from 7 years ago, different atoms, completely different. Almost every atom in your body has been replaced. The pattern is the same, the forces are the same, but the actual atoms, different ones, and those new atoms never touched the old atoms. They never touched you. They never touched anything. They just moved into position, started interacting electromagnetically, started following the quantum rules, and became part of the pattern. This is what Feynman kept trying to get people to understand. The world is not what it seems. Reality is stranger, more beautiful, more mathematical than our everyday experience suggests. We evolved to detect electromagnetic forces and interpret them as touch, because that's useful for survival. We evolved to see patterns of atoms and interpret them as solid objects because that helps us navigate the world. We evolved to believe in contact, in solidity, in substance. But it's all translation, all interpretation, all illusion built on top of something much stranger. The truth is this: you are a cloud of mostly empty space held together by mathematical rules, floating through a universe of other clouds, interacting through invisible forces, experiencing electromagnetic repulsion as reality,
and convincing yourself that you're touching things. You're not touching anything. You never have, you never will. Every kiss is two force fields pushing against each other. Every handshake is electromagnetic repulsion mistaken for contact. Every step you take is you hovering nanometers above the ground, held up by quantum mechanics. And once you see this, once you really understand it, you can't unsee it. Every time you touch something from now on, you'll know. You'll feel the resistance and understand it's not the object being hard, it's electrons repelling electrons. Force fields interacting. The Pauli exclusion principle refusing to let matter overlap. You'll put your hand on a table and know there's a gap. Tiny, invisible, but real. Your hand floating above the surface. Never making contact, never touching. Just electromagnetic force creating the illusion of solidity. This is reality. This is what's actually happening every moment of every day. Forces in empty space. Quantum rules constraining possibilities. Mathematics made manifest. And the most beautiful part? None of this stops the world from working. The table still holds your coffee. The ground still supports your weight. You can still hug someone and feel connected to them. The experience doesn't change. Only your understanding changes. You're still floating through life, surrounded by force fields. You're still never touching anything. But now you know. Now you see the universe as it actually is, not as your senses pretend it to be. And that's what Feynman wanted. Not to ruin the magic of touching things, but to show you the deeper magic underneath. The magic of electromagnetic forces and quantum mechanics, creating the entire tangible world out of mostly nothing. You've never touched anything. And that's more beautiful than if you had.